right, welcome back. We're going to talk about section 1.3, which is charge and current. Obviously very important in electrical engineering. Charge and current. So the charge on one electron is minus one electron is minus 1.602, we'll leave that off, times 10 to the minus 19th coulombs. That's getting close to the edge, sorry about that. And 1 coulomb contains 6.24 times 10 to the 18th electrons. The law of conservation of charge states is very important. It tells us that charge can neither be created nor destroyed, and the motion of charge is what creates an electric current. Now, if you've had physics, this is going to mess you up a little bit, so bear with me. So we have some sort of dummy material here, like a pipe. We have electrons moving this direction. If the electrons are moving this direction, then we say that current is going this direction. So current moves in the opposite direction of the electrons. So the confusing part here is if you've had physics, in physics we define current moving with electrons. In electrical engineering, current moves opposite of electrons. Electrons going this way, our current is going this way. And the motion of these electrons is what makes us have current. So the electric current is the rate of change of charge. So how much charge, how many electrons we move with respect to time. So current is I. Sometimes we'll do a lowercase I, sometimes we'll do uppercase I. Uppercase is typically reserved for DC circuits, lowercase AC, but we can mix and match here. Now right now we're talking about AC because we're talking about with respect to time. So current is dQ by dt. So Q is our charge. T is time. And I is current. So let's look at our units. That's saying that 1 amp is equal to 1 coulomb charge per 1 second time. So I have an amp equals a coulomb per second. If we want to look at the charge transferred between two times, let's see if we can get this up here, then we need to integrate, right? So the integral of I with respect to time from some initial time t naught to the finish time t is equal to Q. So this is our charge transferred between T0 and T naught. Between times T0, or T naught, and T. All right, so again, there's two types of charge. We have AC, that's alternating. Sorry, two types of current. I think I said charge. And we have DC. DC is direct. That does not have two R's. So we can fix that. Direct current. So alternating current. AC. Current alternates. Not trying to be a smart aleck there, but that's what that means, right? And that's the type of current that is coming out of our wall outlet. We have an AC current. DC, direct current, always the same value. So we always have the same amount of current. We always have the same amount of voltage. It's flat. So that's the end of section 1.3. You can watch the next video for some example problems.